So welcome, and thanks for coming. This is going to be WinDbg for .NET developers. It's kind of not exactly the right audience. WinDbg has this reputation for being a very hard tool, for being something that only like hardcore C++ people can only use. I hope to show you some examples of where it can be useful for .NET developers, where you can use it to debug .NET applications, where you can use it to solve some really hard problems. How many of you used WinDbg before? Okay, so quite a few. I guess maybe even a majority of the audience. So I hope to show you some new things. And for those of you who haven't used WinDbg before, I hope to show you what this tool can do for you. So sort of the rough plan. I want to start with some tips for making WinDbg friendlier, making it a little easier to use for .NET developers or anyone really. I want to talk about the power of scripts and breakpoints, which in a lot of cases help me solve problems I just don't really see any other way of figuring out, especially on Windows. We'll talk about some useful extensions. WinDbg has a nice extension model. You can load extensions that run arbitrary code that will help you figure out things the core debugger itself can't do. We'll talk about startup debugging and remote debugging a little, because these scenarios are also quite easy in WinDbg. And Visual Studio, which I guess is the debugger most of us use every day, can't do probably 50% of the stuff I'm going to show you. So this is why I show you these things using WinDbg. It's not just because it's such a fun tool to use. It's because it really has some power that Visual Studio doesn't have. So is Visual Studio a powerful debugger? Who thinks Visual Studio is a powerful debugger? Don't be shy. It is quite good, right? But it's a toy for people who like clicking things with the mouse, or you have keyboard shortcuts. But generally, compared to the power of debuggers like GDB, what's up with the audio? So GDB, DDD, WinDbg, which we're going to be looking at, compared with these debuggers, Visual Studio is kind of a toy. And I use Visual Studio every day. I use that debugger, but it is still kind of a toy. We don't have macros anymore as of Visual Studio 2012, so it's really hard to extend the debugger with scripts or something like that. There's virtually no extensions for the debugger engine itself. Visual Studio is great if you have source code, but if you don't have source code for a particular thing you have to debug, it's a lot harder to do anything, pretty much impossible to do anything if you don't have the source code. So I like Visual Studio, but I think, again, there's some cases that need a more powerful option. So I guess maybe some of you have seen the original of this diagram. It's typically for Linux distributions. So like the shortest beard is Ubuntu, and then the slightly longer beard is Fedora. Then it goes on and on. So Visual Studio is the shorter beards, and then the real geeks, they use WinDbg, and then the real geeks, they use CDB, which is a console-only version of WinDbg, and so on. So there's always something else to learn and be more hardcore. So we're going to make WinDbg great again, hopefully. Let's take a look at some of the things that make it a little easier to use first. So one of the things that makes WinDbg so scary is that you have to remember a lot of commands. There's some menus, some shortcuts, but generally you have to type in a lot of text commands. So it turns out WinDbg has this nice command that you do have to remember called cmd3, which can create this nice menu for you. You can then navigate with your mouse the way you like. and that will run useful commands for you. So on one of my GitHub repos that I have at the end, I have an example command tree file, which will open up for you this kind of interactive tree where you can find useful commands, groups by category, and then click them and run the command. So that makes things a little more discoverable. And for people just getting started with WinDbg, this can be really useful. Next, I guess a lot of people don't like WinDbg because the command output is so scary, and you always have to copy-paste stuff. You always have to take the output of one command and you have to give it to another command. So there's an option that's been enabled by default for quite a while in WinDbg versions called DML. DML is Debugger Markup Language, and I'll show you an example of that in actual a bit later. For now, however, you'll find that in recent versions of the debugger, a lot of command output has links inside. And then you just click the link to get something else. So in this example here, I ran a command called name2ee, which takes a class name, in this example, some C# class, and gives me some information about the class, like which assembly it is in. But then a bunch of the output has additional links that I can click. So for example, if I click the link next to the EE class, I get this. It runs another command for me that prints out some information about that type. So among other things, you can see fields at the bottom, and you have the field type and some additional information about that field. Links that you can click. And if you click these links, you will get some information about that field's type, and so on and so forth. So exploring stuff when you don't really remember all the commands can be a lot more useful if you have extensions, if you have tools that give you these little links. And I'll show you an example of an extension that outputs these links a little later. Another thing that makes WinDbg a little scary is that some simple things can take a lot of typing, to do. But here, another useful thing a lot of people don't know is you can run WinDbg and tell it to script for you, to run a bunch of commands and then just exit. So I want to show you a couple of examples of this. Essentially, WinDbg has a -c switch, which takes a command line, and it will run that command line when it opens, and then you can also instruct it to close, to terminate. So in this example, I have a dump file of some process that failed. Let me actually run this as a live demo. So in my c/temp folder, I have a number of crash dumps over here for processes that crashed on my system over time. And in this console window, I'm just going to remove the prompt. I have WinDbg, and I also have CDB, which, like I said, is the console version of WinDbg. And so I can tell CDB to just open one of these dump files, like this file explorer dump over here, that the Z switch is for dump, because it makes sense. And then the -c is a command to run when you open that dump. So I can do open a log file, ctemp crash log, and then don't forget to close it, and then don't forget to quit. But in the meantime, run an analysis command. Analyze-v is a command that analyzes that crash dump and gives me some useful information. So here's some basic debugger automation right there. I can run the debugger, attach to a dump file, run analysis, put the whole thing into a log file, and exit. And this is repeatable. I can do that in a batch file. So I'm going to run this. This is CDB. It's the same thing as WinDbg, except it doesn't even have a window. It's all in the console. The hardcore folks like it. And so it's doing the analysis right now. It's a little slow because it depends on an internet connection to download symbols. So if it doesn't finish, I'll just mention that in the result, there's some interesting lines that give you information about what happened in that dump. So for example, you can see I ran findstr on the output result to find the process name that crashed, the exception that happened, which was a null reference exception in some particular function, I also have information about the operating system, the version of the CLR, so this analysis has a bunch of useful stuff. So again, this is just an example of taking the debugger and automating it, right? Running some commands to run, and then stopping it. Another example of this is something I've been doing a lot when chasing memory leaks. When you have a memory leak, you often see the process getting bigger and bigger, and you want periodically to just attach what's going on and then detach. So here's how you can do that with WinDbg. In this case, I run it, again, I run CDB because I like it more. I run CDB, the PN switch. So this is a particular process I want to attach to. This is the process that might be leaking memory, for example. And then the command I give it is dump heap, which prints out the statistics for my .NET heap objects. And the min switch means I only want objects larger than 10,000 bytes in this example. And then the QD at the end is quit and detach. So essentially what this command will do whenever you run it is attach to the process, print out the top heap memory consumers over 10,000 bytes, and then detach and keep the process running. So this is like an instantaneous way, almost instantaneous, of figuring out what's happening in your process's memory. And again, you can run this as a little batch file, so it doesn't stop things for a very long time. Good luck doing something like that with Visual Studio, for example. So I hope some of these automation examples really show that once you have the power of the debugger, you can also run it automatically, you can script it, you can put these things in little reusable units. And to really benefit from these reusable units, you need to understand how the debugger scripting language works. And this is the trickiest and most hardcore part in WinDbg. It has a scripting language. Again, it's a debugger, but it has a scripting language. But that language was never designed. It's not like C# that has a language design committee, you know, and peer review and that kind of thing. It's a language that sort of just appeared over time, and then someone hacked a little on it, and someone else hacked a little, and then that's the result we got at the end. So let's take a quick look at this script, and there's a lot more examples I can show you, and there's tutorials for this. We're not going to do like a WinDbg scripting course right here. So the first line here initializes a variable called t0 to the value 0. That's pretty easy. The second line places a breakpoint in a particular function. The function is called NT-allocate virtual memory. This is a Windows API that allocates memory. All memory allocations at the end have to go through this function, have to go through this API. And whenever that breakpoint is hit, when we actually call this function, what I want to do is run the command inside the quotes. And what this command does is it increments the t0 variable with some scary expression, with this scary expression over here. So RDX is a register, and it has the amount of memory allocated. And then I hit G to let the application continue running. And then when I stop it, I can use the printf command to print out the current value of the t0 variable, which will tell me the total amount of virtual memory allocated while this little thing was running. So we place a breakpoint. The breakpoint increments a variable with the number of bytes allocated. And then whenever I want, I just dump out that variable, and I know how much memory was allocated. This general approach of putting a breakpoint somewhere and having that breakpoint do something for you is extremely, extremely powerful. In Visual Studio, a lot of us use breakpoints to just break, to stop into the debugger and then start moving the mouse around, pointing at things. This is fine, I do that as well. But the real power of breakpoints is when the breakpoint works for you and not you work for the breakpoint. So a couple of examples of this. Say I have this application creating files, and I don't know where these files are coming from. It's just creating these files, and it keeps creating them, and it's not deleting them, and in fact, they're not deletable. It locks them, right? So while the application is running, I can't delete these files. Does it ever happen to anyone here? Okay, so I want to figure out where these files are coming from. There's a bunch of ways to do this, but like the most brain-dead thing you could do is just put a breakpoint somewhere. Let's put a breakpoint where we are creating files and see where it's coming from. So I'm going to put a breakpoint here in the two Windows APIs, the two principal functions for opening files, which are create file W and create file A. These are Windows APIs. Whenever I hit those, I will print the file name that we are opening, which is in here. ESP is the stack pointer, and the stack pointer +4 is where the first function parameter is. You're not supposed to remember this. You can discover this by looking in the debugger. And then if you're calling create file W, the file name is a Unicode string, so I use the MU format. And if it's create file A, the file name is an ANSI string, and then I use MA for that. And after I print the file name, I print 3 dashes, and then the K command shows me a call stack. So the result of this whole thing is that whenever my application opens a file, I get a nice printout in my debugger that says which file I'm opening, like you can see on the bottom over there, which file I'm opening, and what the call stack is, how we got here. In this example, it's a C++ call stack, but the same thing exactly can work for a .NET application, and print out which stack is opening files. I'll have a .NET example for you as well. So like the basic idea is, put a breakpoint somewhere and have that breakpoint work for you. Have that breakpoint calculate something for you, aggregate, print something out. So a couple of additional examples. My app complains about missing files. So it fails to open some file. It doesn't tell me why. It doesn't tell me where. It has this stupid error message, can't open the file, or something like that. Again, happens to me a lot. Just place a breakpoint, right? Except in this case, it's a slightly more sophisticated breakpoint. This breakpoint has to discover that the file couldn't be opened, that there was an error. I couldn't open the file. So the way we do that is we place a breakpoint in create file W. Actually, sorry, this offset shouldn't be here. Ignore the offset. So we place a breakpoint in create file W, and then the GU command will run until the return from that function. So we go into create file W, we run until the function returns, and then we stop again. And then we inspect the EAX register. On 32-bit Windows, EAX is where the result from the function is. On 64-bit Windows, it's going to RAX, essentially the same thing. If the return value is 0, it means create file failed. So there's an if statement there. So the debugger sees, okay, the call failed, and then what I do is I print out which file I failed to open. And again, I can print the call stack of where that happened. So again, the debugger is working for me. I'm not working for the debugger. I'm not trying to find in my code all the places where I could possibly open a file. I just tell the debugger, let me know when you see a failed file open. Here's an actual example from Stack Overflow. So here's a long question. This guy is like looking to understand something, this and that. And then at the end, he's like, okay, so this definition makes me ask, okay, so who is making the calls to virtual alloc? Is it the heap manager or the .NET runtime? Who is calling that function, that virtual alloc function? I guess you know the drill. We put a breakpoint in virtual alloc and we find out. This was actually I mean, people wouldn't even suggest that at first. And it's like the obvious thing. You want to know who is calling that function, you put a breakpoint in the function and you find out. It can't be any easier. So we place a breakpoint in virtual alloc, and then we print out the task to allocate. And we also print, and this is the example I was talking about, we print both the native and the managed call stack. So in this example, you can see I'm allocating virtual memory from inside the garbage collector. The stack says gc heap, grow heap segment, virtual alloc commit for heap. And that was called by XML dictionary read content something. So I'm trying to do something with XML, and that ends up allocating virtual memory. So again, there are no surprises. And this technique of placing a breakpoint somewhere and having that breakpoint work for you is possibly the most important thing I can tell you in this talk. It's so incredibly powerful, and we just don't have that in Visual Studio. We can usually only put breakpoints in functions we have the source code for. You can sort of, in Visual Studio, put a breakpoint on other functions, but people don't use that because it's not really friendly. I can't say the WinDbg way is very friendly, but it's very powerful anyway. All right, so something totally different now. Suppose you have this huge collection of objects, and in that collection there is one bad object. And I want to find this one bad object. How is it bad? For example, it contains this character A with a little round dot on it, and that breaks my encoding and I can't use it and whatever. It's a broken object. So how do you find this one broken object? It is not very pretty, but it works. We'll see another way as well towards the end. So first, we find where the object is. Like, what is this object I'm looking for? It's an order object. Okay, so we find that. And then I dump the class to figure out where the field I am looking for is relative to the beginning of the object. So I'm interested in this field over here, the address field, and you can see here it's at offset 4 from the beginning of the object. So if I look at offset 4, this is where the address is. Great, so all that's left to do is find all the objects on my heap that are offset type, that are of the order type, and for each object on my heap, I have to find the string that's at offset 4 from the beginning of the object, and then I have to look inside the string and see if it has that A with the round dot on top. And here's what it looks like. You don't have to read this. It is painful for the eyes, but it basically does the job. And notice a few key things. There's a loop in here. There's a for each loop that your debugger is running for you. This is pretty crazy. And in this for each loop, there's some additional if statements. There's actual program logic going on there. And it's not like there's no other way to do this, but it's probably easiest actually with WinDbg rather than writing custom code to now look at this collection of objects, which is something you can only do if you actually have access to the system that's currently running that code. So the result is that, yep, some object has this address 233 Hampton Street with a dot on top, and that was the object I was looking for. So again, the idea is we tell the debugger to run a program for us. One final example from the cool commands you can use before we move on to extensions is a really obscure command not a lot of people know about called WT. What WT does is trace execution flow. You give it a function, and then you run WT, and it prints out all the functions called by that function, like a complete graph of calls. And you can limit the depth. So what I did here, I was like, I'm curious what the garbage collector is doing during the mark phase. So let's put a breakpoint in a function in the garbage collector called mark phase. That was easy. And then run WT. And then you get this nice tree. I asked for just depth 1. So you get all the functions called by mark phase. So if you're interested into how the garbage collector works, there's a lot of detail here. So it calls generation size and GC scan routes and scan background routes and a bunch of other functions. The complete output is like several pages long. And then at the end, there's this nice report with all the functions and the number of instructions executed. So you can see the expensive functions in terms of number of instructions were these guys: mark through cards for segment, mark through cards for large something, it was truncated, and a bunch of others. So this is like a tiny, poor man's profiler right inside the debugger. It's like there's nothing this debugger can't do. It's like Emacs, right? Emacs can do everything. This is sort of like what WinDbg is as well. So what I want to do now is show you a couple of cool extensions. And I'll start with an extension that lets you script the debugger using something less horrible, not as bad as the scripts you saw before. And this is a pretty cool extension called PyKD. What PyKD does is let you run Python to automate WinDbg, to run WinDbg commands, to parse output, to do stuff from Python with WinDbg. And so this example I have on the slide, it's not really super interesting. It just tries to fix the stack if the stack is broken. The idea, however, is you have a Python API for most of the things that WinDbg can do. So if you have like this really complex script, instead of writing it in the horrible WinDbg language, one option is to use the Python language. And I have what I think is a pretty nice script built using PyKD, which I called heap-stat.py. This is actually not for .NET, this is for C++ applications, but it gives C++ developers part of the same functionality I showed you before, where you can look at the heap and see what objects you have in there. So for .NET, we saw that it's pretty easy. For C++, it's kind of hard. And this extension, what it does is a Python script that walks the C++ heaps, finds objects, and prints out the number of objects of each type. And in some cases, it can also tell you the total size. So this is sort of like heap walking for C++. And doing this using just the WinDbg scripting language would have been really hard. Doing this with Python was sort of pleasant even. It's Python after all. So that's one cool extension, PyKD, which lets you use Python to script the debugger. Let's take a look at some more extensions, and I also want to show you an example of actual code of what an actual extension looks like. The extension model is pretty simple. Basically, every extension to WinDbg is just a DLL. You can run it in C++, you can write it in C#, you can write it in any language that has exported functions. And then the debugger load your extension and just run each exported function as a command. Your extension has access to the debugger APIs. So for example, if your extension wants to print something, wants to look at objects in memory, that kind of thing, it can access the debugger interfaces back. So here's a simple extension that's also on GitHub, which I built just for the purpose of demonstrating what an extension looks like. This is an extension that browses to an HTTP URL. So you can, from within the debugger, do an HTTP request, print out the resulting HTML. So this is C#, it's pretty simple, you know, web client, download string, that kind of thing. And let me show you what the result looks like. So let me just run WinDbg here. And I need some process to attach to, so let me just run like Notepad or something. Okay, and now I'm gonna load my extension. Oops. x86, debug. And now I can do stuff like go to google.com. And if the internet connection works, we get output. So it redirects to Google Ru probably, so it's Russian. I haven't taken care of the encoding here. But what you'll find is interesting that these things are actual links in the debugger. So your extension can actually output these links I was talking about and makes things more discoverable for the user. So if I click Blogger here, you'll notice at the bottom of the screen, it's just doing another request to another page. So we have this super simple text browser embedded in our debugger, or not, you know. There's still some issues to work out, but this is a very simple example of a debugger extension, and I hope can serve as a starting point. So if you're interested in building your own extensions that can do something really powerful that you find yourself doing over and over, just repetitive work, you can use this as a starting point for developing your own extensions. It's not really hard, and you can do it in C#. It was actually pretty surprising that you can do it in C#, but you absolutely can, and there's no particular issues there. Okay, so let's take a look at some of the existing extensions, so we don't have to write our own. Here's a sample, pretty typical situation I have to deal with when debugging 64-bit code. 64-bit code on Windows has a calling convention which makes it really hard to retrieve parameters when you're running optimized code. If you have code compiled for release, it might be really hard to figure out what the function arguments were. You might not see this every day, but if you debug a lot of optimized code, you will hit that time and again. You want to know what the arguments are, and you just can't. Like, the debugger won't show you the arguments. And it happens in Visual Studio, and it also happens in WinDbg. So in this example here, I have a function called wait for multiple objects that my application is calling, and I really want to know what the arguments were, but the debugger says no data, no data, no data, no data. There are 4 arguments, so it says no data 4 times, you know, just to be clear. So there's this really cool extension called CMKD, which can do parameter reconstruction. It basically tries to use clues, like any hint it can find, to see if it can recover the function arguments. And in this particular case, the extension is loaded, and then we run the stack command. And so it says, sure, you called wait for multiple objects. Here's the arguments, the first, the second, the third, and the fourth. You have to cross-check, you have to make sure the guess is right, because it uses heuristics, but it also tells you how it got to that conclusion. In this case, for example, it says, this argument was in a register called RDX. And the function we called actually put that argument into another register called R13, and R13, some other function down the stack later, saved it to the stack, saved it to memory, so we can fetch it from there. Now, good luck doing something like that yourself, right? Whereas here, there's an extension that just recovers the arguments for you, sort of does lots of the hard, annoying work. This is an extension I really like and use often. For .NET code, for C++ code, all 64-bit code on Windows pretty much has this issue where if you compile with optimizations, it gets really, really hard to recover parameter values, and CMKD can take care of that for you. Another cool extension, which is really important that you know about, is SOSEX. I bet a lot of you who've been using WinDbg before have been using SOS, which is like the go-to debugging extension for .NET applications. This is what you use to debug .NET in WinDbg. SOSEX is kind of what SOS should have been in the first place. It was developed by a guy called Steve Johnson. He's actually a Microsoft engineer, but this is his spare time project. It's not his job to build SOSEX, and he still that. One feature I really like in SOSEX is heap indexing. If you have a very big .NET heap and you want to look at objects, you want to see which objects are referencing other objects, if the heap is like 10 gigabytes, every command you run is going to be very, very slow because there's lots and lots of objects on the heap. So what Steve does is he builds an index first, like in a database. He builds an index of the heap so you can do stuff faster later. So this example I ran here is basically running a loop, again a for each loop. For each byte array on my heap, I want to find who is referencing that byte array. Why is that byte array still alive? Like I have a memory leak probably of byte arrays. And the bhi command builds the index, and the mroot command uses the index to tell me, for example, that this byte array object here is referenced by this schedule object, which is referenced by this employee object. The point is, however, is the speed of the whole thing. If you use a non-indexed command, and SOS has one, SOS has GC root for this, then running it 30 times, I measured it roughly, it takes about 5 seconds to run it for 30 objects. Now in this particular example, I had 6,000 of these objects. So there's just no way I would have waited for all these results to come in. Whereas mroot took 0 milliseconds. I literally couldn't measure it. Like I had to run more iterations to even get a meaningful value. So the index is really, really fast. If you have big heaps that you want to analyze in WinDbg, heaps with an EA, big heaps, then this is your go-to extension, SOSEX. Yes? The index, it takes a little time to build. I never saw it took more than like 5 minutes, and then it saves you a lot of time down the way. Another very cool extension I want to show you, we're getting to the end of the extensions here. Another very cool extension is called NetExt. This is also built by a Microsoft engineer out of Brazil, I think, Rod Viana. And again, it's his spare time project. It's not part of his job to build this extension. It was designed for troubleshooting mostly ASP.NET applications, and it has really cool features that have to do with searching for objects on your heap. So in this example, I loaded the extension and then I ran a command called wruntime, which prints out information about any ASP.NET applications I have in my process. This is already pretty useful. And then there's a command called whttp, which prints out all the HTTP requests that I have on my heap. So these can be executing HTTP requests that my server is handling right now, or they can be already completed. And it shows me for each request its running time, status, result, and so on. Some more information you can get about individual HTTP requests will include which URL you were hitting, again, when that request was made, the response information, if there is already a response. So if you're debugging an ASP.NET app, it's extremely useful. And NetExt also has this really nice SQL-like syntax. So you can do queries of heap objects using this thing. It's not exactly SQL, but you can see where it gets the idea. So what we're doing here is from HTTP context objects, select the request.row URL and the response.status code. So this is just going into objects, right? A.B.C, just entering managed objects one after the other. And it prints out, in this case, again, all my executing HTTP requests. And so remember this example with the A and the dot on top? Here's how we can do the same thing with NetExt. It's a little easier. So from all the order objects, where the address property has A with a dot on top, select the object address and the actual address string. So we find that object pretty quickly. Again, it goes over all the objects and applies that query, applies that filter, except we write it using a somewhat easier syntax. This is all well documented. He has a bunch more useful examples on his website, and I have references towards the end. And one final extension I want to show you, at least mention, is one that I built. It's called Tracer. This is a WinDbg extension I built for leak tracing. Like if you have database connections that you open but forget to close, if you have some resource you had to dispose, like a bitmap, but then you didn't dispose. What Tracer can do for you is trace whenever you open that thing, and whenever you were supposed to close that thing, and then it can tell you, here's how many things you opened but didn't close, and where they came from. So that's the basic idea, and we don't have time right now to explore this further. So one final thing I want to spend a couple of minutes on is WinDbg remote debugging, because this is another feature that I think makes it a lot more powerful and useful than what we have in Visual Studio. Specifically, if you've been doing remote debugging with Visual Studio, the biggest pain is that you have to set up Windows authentication. You have to either use a domain where both computers are in the same domain, or you have to set up local users that have the same name and the same password on both machines. It really sucks, the whole process. In WinDbg, there are no such requirements. You can use a password. You can use a variety of transports, including named pipes, TCP, SSL, just plain HTTP, a bunch of options you can choose from. And there's two primary ways that you can do debugging. And I'm just going to show you a very quick demo, and we'll do that instead of the diagrams. So what I'm going to do over here is I'm going to run CDB in server mode, and we're going to be doing TCP, port 5050 with a password, and I'm going to have that thing debugging Notepad. So this opened up a debugger, which is now waiting for connections. And then from another command prompt, I'm going to go to the x86 folder, and I'm going to go cdb-remote TCP server localhost port 5050 password foo. And now, if I just put these two things side by side, just clear the screen here and there. You can see they are synchronized, essentially. So like whatever I type on the left happens on the right. Whatever I type on the right happens on the left. It's just a synchronized debugging session now. And what's cool is that I can have more than one. I can have more than one client connect to the same session. So for example, within Microsoft, this is often used to share a debugging session with people working remotely. You can have friends connect to your debugger, and then you all debug together, right? No, this is actually pretty useful. This is actually pretty useful. And so I want to leave a couple of minutes for questions. Just the last debugging mode that we have in WinDbg is the smart client mode. Unlike the previous example here, you don't run WinDbg on one side and WinDbg on the other side. You run this little thing called debug SRV, which is just a stupid agent that sits there in the background and listens for connections. And then what's nice in this approach is you can have multiple people connect to that server and debug independent processes. Like one can debug Notepad and the other can debug an ASP.NET application. So multiple people can connect to that server and debug at the same time. And what's that? You can also debug the same application because you can also do this. So you can have one client connect to that remote agent and another client can connect to the first client. So you can, yeah, I thought about that. You can mix and match essentially. So I'm gonna stop here with the with the WinDbg tricks. I would leave a couple of minutes for questions. There's a bunch of references here for the extensions I showed, my WinDbg stuff that I did, and you can find the slides both online, and if you want, there's a link in the right corner on top. I hope, sort of, that I was able to convince you that you can use your toy debugger for simple things, for day-to-day debugging, but if you hit something really challenging and your toy debugger can't help you there, it's worth investing in learning something a little more powerful. Breakpoints placed anywhere is extremely powerful. There's really magical extensions out there that can do a lot of stuff, and remote debugging, which I only showed you in a second, is extremely useful and doesn't have to be such a pain as it is with Visual Studio. So what, we have like 3 minutes for questions?
Yeah, something like that.
Yep.
Thank you, Sasha.
Yeah, thank you.
It was a great talk. I suppose you have a lot of questions, so don't hesitate, just raise your hand up.
Можно по-русски, я думаю.
Да, вы можете говорить по-русски, если вам по-английски неудобно. Поднимайте руку, задавайте любые вопросы, совершенно любые вопросы. Наверняка кто-нибудь хочет что-нибудь спросить. Да. Вот человек. Так, сейчас, секундочку, вам принесут специальное устройство, чтобы говорить.
Могу ли я сломать свою любимую новую игрушку, в смысле защиту ее, с помощью WinDbg?
Что-что?
Могу ли я сломать защиту моей новой игрушки с помощью WinDbg?
Игрушки, like a game or an actual game. So WinDbg is not really designed for reverse engineering. There are better tools if you want to do like reverse engineering specifically. I use WinDbg a lot for figuring out how software works, how this program works, how that program works. But for actually hardcore reverse engineering, there's other tools. Like there's a better debugger called Immunity, for example. There's IDA. There's better tools, I think.
Okay. Any additional questions?
Over here. No.
1 second.
Спасибо за доклад, во-первых. Во-вторых, можно как-то переполнение стека с помощью WinDbg отследить? Вот очень часто встречающаяся проблема, то есть через дамп или еще как-то предварительно.
Right, so Stack Overflows. Yeah, sure. If there's a Stack Overflow, there is an exception. And you can capture dump files when there are exceptions in Windows. Or you can live debug it if you can. And then, I mean, Visual Studio can also tell you like what's on your stack. If you have a Stack Overflow, Visual Studio tells you which functions called each other. You can do the same thing with WinDbg, sure. What happens sometimes is that when you have a Stack Overflow, the stack also becomes corrupted. Like something breaks down in the way the debugger tries to recover the structure of the stack. And then in WinDbg, you have more options. In WinDbg, there's some things you can do to work with this corrupted stack, where Visual Studio would just say, like, here's one function, I can't tell you anything under that function. But yeah, I mean, sure, you can debug Stack Overflows.
Okay, one more question from here.
Спасибо за доклад. У меня вот такой вопрос. Я вчера пытался проанализировать дамп. У меня в дампе были закрапчены объекты в хипе, и дамп heap stat он не работал, потому что определялись закрапченные объекты с определенным метатейблом. Как вообще можно такие проблемы избежать?
So if dump heap fails, it's pretty bad. I mean, it means that some key heap structures have been destroyed. What dump heap does essentially, it reaches into the CLR debugging helper called the DAC, and then if that can't give you information about what's on the heap, all you can do is just like go over the addresses yourself and try to figure out what you see. It can be done, like you can build a script where if you know the heap start and end, you can walk everything and just try to look for valid objects, which is typically what dump heap also does. So like there might be cases where dump heap would fail and you would be able to manually recover more objects actually, yeah.